Hello and welcome to video number 33. Today we're going to be talking about simple harmonic motion. Alright, so let's get started. We're going to go with some of the parts of simple harmonic motion. So there's a period, which is represented by T. And then we also have frequency. And then angular speed. All right. Period is the amount of time it takes to complete one cycle. This is from its original state back to, from its original state back to its original state. So let's say we have a pendulum here, and it starts on the left side. So one period would mean it goes to its position here, and it comes back. And the amount of time it takes for that pendulum to go from position 1 to position 2 back to position 1 is a period. Frequency is how frequent that motion happens. And with simple harmonic motion, there's usually two things that we're talking about. We're either talking about pendulums, and that'd be an oscillating pendulum, or we would be talking about oscillating springs. So that could be something like a spring hanging from the ceiling, and then it is extended or compressed, and then it'll go up and down and up and down, and that's the oscillation. Or even a spring on its side, where it is first pulled or compressed, then let go, and it'll be oscillating. So those are usually the things that we're talking about when we're talking about simple harmonic motion. All right, so let's take a look at problem number 33. So here we have a diagram. Okay. Here we have the reference point where x is equal to 0. This is 15 centimeters. All right, and this is positive direction, negative direction. So in the diagram, this object is pulled down to beneath the 15 centimeters and then let go. Also, it says that the period is 2 seconds, 2.0 seconds. All right, so if you remember, a period is when it goes from its original position up to the maximum and then back down. So question number 33 asked, what is the position of the object at time equals 3 seconds? So t equals 3, where would it be? So we know that at time equals 0, it is down here. And then since we can take just half the period, so in 1 second, it would travel up to here, which would be 15 centimeters above x equals 0. And then it would come back down in the other second, and by the 2 seconds elapsed time, it would be back down here. So if we just added 1 more second, it would be at its max again, which means it's 15 centimeters above x equals 0, the reference point. So at time equals the object is at 15 centimeters. And this is answer